Hi there, we're looking at factor trees, also prime factorisation if you prefer, and also looking at lowest common multiples and highest common factors and using factor trees to find those. So a few things really. Okay, first of all, you'll see I've listed the first 15 prime numbers. Knowing your prime numbers is quite useful when you're doing a factor tree because you know when to stop. So the first thing I'm going to do for our factor trees is it's all about finding pairs of numbers that go into the one above. So a pair of numbers that will multiply together to give 45. 5 would seem like an obvious candidate. 5 times 9 will achieve that. For 36, we go for 12 and 3. Now, you'll see that if I go through my list of prime numbers, 5 is a prime number. So I can circle that because I can't go any further splitting this up. I could go for 1 and 5, and 1 and 5, and 1 and 5, but therefore that wouldn't get me anywhere. So I can circle that one and now I'm finished on that branch. However, 9 isn't a prime number, which means there's another pair of factors other than 1 and 9 that I can split it into. In this occasion that will be 3 and 3. 3 is a prime number, so I can circle that one and that one, and I know that I'm done. So that means that 45 can be written as a product of its prime factors, which means if you do 3 times 3 times 5, you will actually get 45. 3 squared times 5 will be the preferred way of writing it, and this is 45 as a product of its prime factors. Because 3, 3 and 5 are prime and they are factors of 45. For the next one, if I finish off this one, 3 is a prime number, so that will do. 12 can be split up into 3 and 4. Could have used 2 and 6 and you still end up with the same result. 3 is prime, but 4 is not, because it can be split into 2 and 2, because they multiply to give 4. But they are prime. So I'm all done with that one, which means that 36 as a product of its primes is 2 times 2 times 3 times 3. So we've got 2 squared times 3 squared, and that's the product of prime factors for 36. You may just be asked to do that in itself. So show the prime factorisation of these two numbers, and this would be your answer, and this would be your answer. But we can take it a little bit further than that. So what I'm going to do now is I'm going to find the highest common factor and the lowest common multiple of 45 and 36. Now I'm going to do that using a Venn diagram. A few different ways of doing it, but this is one that always kind of works. It always works. Doesn't kind of work, it always works. Okay, don't need that third circle there. So the two ovals are going to basically represent factors of 45 and factors of 36. Now you'll see in red, I mean prime factors, you'll see in red we've got those numbers there. So if you look through, we've got 3's in both. There's only 2's in this one, there's only 5's in this one. So we're going to start the ones that appear in both. So there's at least one 3 in both, so I'll put that in the middle. There's also another 3 that appears in both, that goes in the middle. If there was another 3 in one of them, it wouldn't go in the middle. If there's another 3 in both of them, it would. So 36 has got a couple of 2's, and 45 has got a 5. So to find the highest common factor, you take all the numbers that are in this middle bit here, and you multiply them together. The highest common factor is 9. For the lowest common multiple, you take all of the numbers that appear in this bit, in the two circles. So that means we've got 5 times 3 times 3 times 2 times 2, and that will give us 5 times 9, which is 45, times 2, which is 90, times 2 again, 180. So for these ones, the highest common factor of 45 and 36 is 9, and the lowest common multiple of 45 and 36 is 180. You could have found that lowest common multiple just by doing multiples of 45, multiples of 36 until you get the same number in both. But this is just a more advanced way of making sure that you can find both more easily. Good luck putting that into practice.